Uh, Good morning to all of you. I am very happy to the Robotics and Artificial Intelligence Federation of India to have organized this event and given an opportunity to interact with the young minds. See, from that time I was a physics student and then later on a physics teacher and a researcher. I have been, the more and more I started learning about the universe, I have been fascinated about two English words. One is the tantalizing, the universe, the dynamics of it, the space-time curves in it, the thermodynamics of that, the instabilities associated with that, then the very complex nature of the whole thing, defying most of the mathematics that we know, is tantalizing. Then the other word is the word precious. See, the life that we have here, our own life, the life that we have on this planet are so precious when we just see what has been the environment endowed with the earth. So close to sun, an unsafeguarded nuclear reactor, and amidst the instabilities associated with the universe. So we are gifted to have life here, and we should be thankful to the nature for that. So with this small introduction, we will just go on to the universe, some of the ideas with the time constraint of about 20 plus 10, 20 minutes of speech and 10 minutes of interaction with you. We will just go ahead and we will just see how things can be. So the universe, where Earth is components, two major components, the magnetic field of Earth and the atmosphere of Earth, the planets of the solar system, our own central star, the sun. Separated by it, the interstellar space, the stars. Then we have like this about 400 billion stars constituting our galaxy, the Milky Way. Probably today's children, if I ask which is the most fascinating galaxy that they like, they may say Samsung Galaxy S5. But now the Milky Way galaxy that we have is very wonderful. It's a spiral galaxy. We'll just see some more facts of them. Then we have the intergalactical space. Like this, we have billions of galaxies. So now, one thing is sure, that to live on this earth, we should understand nature better and better. There is no other go. If you want to live comfortably, yes, we need to understand nature better and better. That's only through science and technology. So with the present day knowledge of what we have, if we just see, go through. Now, this is the sun, the third planet is the earth. So now it is so close. Had this earth been some 10% of the distance closer to earth, the temperature would be around centigrade and life would not have been possible. At the same time, had it been 10% of the distance away from earth, the night temperature will be around minus 40 degrees centigrade, and again life might be very precarious. So we have been in the right position, and we have been talking about the radiation disposal methods and the waste product, nuclear waste disposals in Kalpakam or Kudangalam or other nuclear reactors, where the annual consumption is less than a ton of material. But see, the millions of tons are being, as nuclear waste, are being thrown out by the sun as an unsafeguarded nuclear reactor, and we are so close to the sun. So these things should make us be more responsible citizens. Now, it is true that ionizing radiations and a lot of radiations come from the sun in the form of solar wind. Luckily, the Earth's magnetic field saves us. Most of them get into the solar cap regions around some 30 degree space near the South Pole and also the North Pole. The rest of the Earth is habitable and safe. By is safe. So the Earth's magnetic field forms a very crucial and critical component in sustaining life on this planet. We have this Milky Way galaxy where we have about 400 billion stars around, and it is 120,000 light years across. For the young minds who are, some of them are from the schools, the light year is a unit of distance. The distance traveled by light in 1 year time in vacuum. So it's around a little less than 10 trillion kilometers. It's called as 1 light year. So with this in mind, if you just see some of the interesting facts coming over this, we would like to know, we would like to address the question, how this wonderful universe has come to existence. So probably if you can just think of, then it's probably a very complicated thing, but in science we say often the complicated problems have got simple solutions. The only thing is we have to unknot it. So that way we just see one of the thing is that, one of the clue is that if you just look at the night sky, we are having millions of stars around us. Beautiful night sky we have. So let us try to perform a thought experiment and then a real experiment. We have so many stars of them moving. How many of them are coming towards us? How many of them are going away from us? If you just try to find out, make a measurement. And if you really make a measurement, what you find is that all of them are going away from us only. Not even one of them is coming towards us. So now the question is that, why all of them go away? Why all of them go away from us? Right? So that's a single point to be thought over. Because as such in the universe, our earth doesn't have any universe. So they don't have any reason to go away from us. Away from us. There is no reason. But the fact is that all of them are going away. So we just think of that. What is happening is that if you just try to have a balloon, half-blown balloon, have a lot of dots on it, and then if you further blow, then each dot will be going away from every other dot. That means the balloon is expanding, so also is expanding. So we are in an expanding universe. So one small simple thought experiment as to of the stars, how many of them are coming towards us and how many of them are going away from us, gives us a clue that these all the stars are going away, means that the universe is expanding. Now if you think it in the reverse, if they have been keeping on expanding, go time reversal. So at one point of time, there should have been, from a single point, should have bursted out. Probably we can call it as a singularity, or a small point, or a 11 size, where all the matter, the energy, mass, everything would have been concentrated, but anyway from a single point it would have come out at some point of time. Then will it be possible to find out this would have occurred? Yes, we will see. So now if you just see, the clues come from two simple observations. How does the stars move with respect to the earth? And then there is a background microwave radiation 24/7 coming from all directions. This means that the universe is expanding, and then the microwave background radiation mean that there was an initial burst. These things have been confirmed, and appropriate Nobel Prizes have been given to those people who have been proposing those things. Now, so there was a big bang from which the whole universe started. And it's about 10 billion to 20 billion years ago, to be precise. It is about 13.5 billion years ago. So probably this 13.5 billion years ago, this number 13.5, you may remember, put it in your corner of the mind, where there is a magic number. We will now come to that a little later. So now when we have this, can we have a chance to look at this early universe? So if I want to see you as you looked yesterday, no, that's not possible. We come one day ahead. So it's not possible to look at you how you looked yesterday. But now, as we said, the universe is tantalizing. It's very fanciful. It's very fascinating. So now if you just see in this thing, we have the earth marked as 1. Our nearest star is the Alpha Centauri, and the distance between them is 4 light years. So, the light starting from there takes 4 years to reach us. So, tonight if I go to the terrace, look at Alpha Centauri, the star. Yes, the star is there. If I look at it, then can I say that star is existing now? No, because the light which I am seeing from the star now has left the star 4 years ago. So, it only means that the star was there 4 years back. So, if I just take a photograph of that star now, I am taking the photograph of the star 4 years ago. Or reverse of it, imagine now you are locating yourself on the surface of Alpha Centauri, look at the earth, then I can see you 4 years back how you looked, played football, things like that, I can look at you here. So, now this 4 years gives you an edge of seeing something go into the past and look at how things looked. So, if that be the case, can I go still farther away, like having a better microscope, better telescope, better procedures, better algorithms, and look at more distant stars, more distant galaxies, so that I can look at the earlier and earlier part of the universe. So, in the attempt towards that, see, this is some of the facts. Light takes about 4.37 light years to reach from here. Actually, it's a binary system, doesn't matter about that. So, now when we want to look at the early universe and we want to know about the formation or the birth of the universe, then now my target is to go deeper and deeper into the space and look at it. So, I have more powerful telescopes. Not necessarily in the visual region, but also in the radio region. So, put all your mathematics at work, synthesize the signal, do the image processing, get as best an image as possible. That will give you as best a clue as possible. So, with this in mind, if we just proceed further, one of the man's attempts to see further and further is the Hubble telescope. The problem is that if we have a land-based, surface-based telescope, then the distortions to the Earth's atmosphere is very serious. That distorts, so that the resolution is compromised, so we are not able to get clear pictures. So, we should be going away from this. Yeah. So, that is why the Hubble telescope has been launched, and it sends some beautiful pictures, extraordinarily good pictures it has been sending, and you might have been probably looking from the news reports in the papers that excellent pictures have been coming, many computations have been made based on that. These are some of the wonderful pictures that have been sent by the Hubble, and especially the red one that you are able to see, that is a galaxy which is at a distance of 13 billion light years. I told you the Earth the whole universe might have been formed at around 13.48 billion light years back, but now we are able to see up to 13 billion light years. That is about 95% of the targeted distance. Now we are able to look at it. So, probably if you just go to some star system 100 light year back, then probably from there if you look at the surface of Earth, probably you can see your grandfather playing, and if you go some 200 light years back, your forefathers some 3 generations back, you can see playing on the surface of Earth. Now, we are able to go back to 13 billion light years, that is 95% of that distance, that the targeted distance we are now able to go through the existing Hubble telescope. The only thing is the remaining distance, there are limitations of the Hubble coming over. So, now the NASA and Boeing are now trying to design a new telescopic system that they target to launch by 2030. That they feel they can go within few light years of the Big Bang. We will see. So, with this 13.1 billion we are able to go through, and remaining about 0.38 billion light year we want to target to look at. That's the effort of mankind. Now all the technologies, all the science, all the mathematics, all the technology at the disposal of the mankind, we are able to push this frontier further and further. I feel the contribution and innovation of the young minds will be very great to contribute towards this. This is not a problem of India or America or anybody, it is a problem of mankind. The mankind wants to understand the universe better and better. So in that, all of us belong a part of mankind. So we have a duty to contribute towards this. So now, when the speed of light being very, very large, unless we break this another 0.48 billion light year distance, we will not be having further conclusive proofs. We have theories. To corroborate the theories, we want experiment. How the science and technology grows is that on one side we have theory, on the other side we have experiment. The theories will be predicting something, the experiments will be verifying. Sometimes the experiments will be giving out some data, the theories will be developed to fit in that. So the theory and experiment go hand in hand. So that's how the science and technology grows. Especially that's how the modern science grows. By modern science, what I mean is the science after 1700. So by a very simple trick, the mankind was able to unknot a very difficult problem in science and technology. So the birth of modern science from 1700 till today, in this 300 years, the advancements we had is many fold times greater than the advancements till 1700. The reason is that earlier, probably this I should share as a teacher to our young friends here. See, if there are several parameters coming over and influencing a phenomenon, before 1700, what they used to do is that change the pressure, change the temperature, change this, that, and then try to come to your own conclusion. That's how they have been trying to analyze science within quotes. But from 1700 onwards, what has been formulated is that if many parameters are influencing a phenomenon, keep all of them constant, vary only one of them, find out its effect on another parameter. So keep all other things constant, find out how this one parameter affects the outcome. Then keep this parameter constant, change one more parameter, find what's the change in the outcome. So at a time make only two of them change, that is one, thank you. So that way the modern science has grown, and the moment this has been done, the whole thing has become very systematic, and then the results were forthcoming and the development was very fast. So some of the facts is that we have a very high solar wind, we are surviving, the whole sun is moving with an orbital velocity, all the galaxies in the arms are just going around at terrific speed, there are instabilities, the thermodynamics is very complicated. In spite of it, we are living in a beautiful environment, so we should be thankful to nature. So now look at this, it's very calm, the night sky looks very calm, but it's very dynamic. It looks very beautiful, but it is really very violent. Remember, some of the processes, the magnitudes involved are so large that it is extremely a violent universe that we are having. Very stable, we can't comment, because many times we feel we do not understand the term very well. I feel I don't understand what stability means compared to the different processes that are going in the universe. So extremely difficult things that are going over. Very much life supporting, very rare combination that made life is possible at Earth. Then to the famous question, are we alone, living and also living intelligent in this universe? Not necessarily. Why should we be thinking like that? That itself is an ego, I will say. So, not necessarily. So, if I just ask this question, what is the aim of life? Probably the young minds can come out with different answers, but scientifically speaking, there can be only one right answer. So, and that is to live as long as possible and as comfortably as possible. That is possible only through scientific understanding of things, nothing else. So, the life is precious, quality of life can be improved only by understanding nature better and better through science and technology, because the physical laws alone, whether we like it or not, the physical laws alone are governing the physical world. That is our wonderful universe. So, thank you. I had a wonderful listening audience. Nice of you. So, any question? There is any? Oh, please be seated. See, is there any limit of the universe? See, what we have been talking by the term universe is the observable universe. And as I say, the theory, unless it is corroborated with the experiments, we don't have a conclusive evidence on that. So, by limit, the term limit again doesn't have a concrete meaning in this context, because by universe we say the observable universe. We do not know what is beyond that, because it doesn't know, the time is not defined, space is not defined beyond the singularity, that is the Big Bang point. We do not know. At t equal to 0, up to that we can have all our theories. At t equal to 0 and before that, no, we don't want to make any guess. We say we do not know. Yes.
When a particular telescope or something takes an image, how do you verify the light is coming from 13 billion light years away, or how do you know the image is that far, coming from that far away?
For that we have excellent calibration procedures available, excellent designs are available, excellent theories are available. So, whenever we want to push in the knowledge of mankind, we always bank upon the theory, the solid mathematics behind it, the designs behind it, and the algorithms behind it. So, probably within the inaccuracies of these things, yes, we thought the ultimate endeavor is to understand nature better and better. Yeah.
So, I am Shyam from Savita University. So, my question is, if we travel faster than light, is time travel possible?
So, see, now as per the relativity, general relativity, the fastest thing is the speed of light in vacuum, right. So, nothing can travel faster than light in vacuum. This is a qualified statement. But if some materials try to travel faster than light in a medium like glass, we all know that Cherenkov radiation will come out, so that it decelerates the particle, and hence the speed is reduced below that of light. So, now the statement is that nothing can travel faster than light in vacuum. That is, as of now, looks like a central pillar of science. So, I do not know anything about God, because I have not studied about that domain. But to this, the different theories of existence of the universe, we say from a Big Bang it all came from a singularity. So, from a single point it came. Then you can probably logically say that again, if all these universe again at one point start collapsing, again a Big Bang, again start collapsing. So, it may be an oscillating universe or vibrating universe, maybe. So, and then we can say, are we in the 437th vibration, or no, we can't say. So, anything the moment that t equals 0 a Big Bang comes, then all the knowledge vanishes because it is a singularity. Yes, please. Yeah. Aliens. Oh.
Talk about the temperature. We talk about.
Yes, I have told you when I asked the last question, when I answered the last question, we need not be thinking that we are the only intelligent living being, not necessarily, because our sun is like any other star. It is only our central star, and 400 billion of them are there in our Milky Way galaxy, and we have billions of such galaxies. So, not necessarily we need not necessarily be the living being and be the intelligent being, not necessarily. Yes? Big? No, I don't catch you. Oh, Higgs boson. Oh, excellent. It's really wonderful that a young friend has asked about that. Only one, because of the taking into time into consideration, just a very quick one, half a sentence I will just offer on this. See, the Higgs boson, we say somebody quote it as God particle and all. Why should they be called as God particle? Because from the biblical origin we say God said, let there be earth, there was earth. That means they say by saying that creation of the universe, creation of mass, that is what they mean. So, now the point is that I am having say 63 kg mass, you are having some 72 kg mass, what that mass comes from? So, we know about the origin of the charge, spin, this, the momentum, energy, those things, but mass how it comes from. So, in 1965 Professor Higgs told that there is a particle and that is responsible to give mass, the property mass to every other particle. So, and it was a theory that was suggested in 1965. Now, the Large Hadron Collider we have reasonable evidence beyond 6 sigma level to confirm that, and now we feel we have discovered the Higgs boson, and that is why the Nobel Prize last year was given to Professor Higgs. Good, nice question. Oh, we have suitable signals, there will be sensors on board, that will be recording the image, and suitably by radio waves that will be transmitted here, we will receive those signals, we will reconstruct that image here. We have the technology for that. Okay? Yeah.
So, I am Sri Harish from Savita University. Is shifting of poles possible in future to Earth?
There are many theories for that, and many dynamics are going on. Whether shifting of poles is possible or not does not matter, but there is a necessity for the magnetic lines of Earth. If the magnetic field of Earth is not there, then we would have been 24/7 bombarded by the radiative particles from the sun and also from the cosmos. As a result, we would have been died many times by now. So, the magnetic field of Earth is very crucial to sustain life here. So, thank you all very much. We had an excellent morning. Thank you. Good day.